Yo, what's up guys, welcome back to another video. This is a reaction to underwater constructions. How do engineers make them? And this is definitely something that you see, for example, like wind turbines and how they're attached to the ocean floor. And it just kind of doesn't really make sense to me, because obviously they're these massive structures that you're gonna have to attach to the ocean floor, like to make it sturdy and to make sure it doesn't fall or collapse. And I always just assumed it would be divers, but I don't really know how you could be a diver and do that. It doesn't seem like it would really be possible. I don't really know, which is why we're doing this reaction. And from what I saw in the thumbnail, it looked like a man-made sinkhole. I don't know if that's what it's called. Basically, just a hole where you suck out the water. And I don't know how that's possible. I could be wrong. Maybe there's different circumstances for different situations. But we're going to check this out and learn about how this is done, because obviously this is very essential for a lot of things in the world. A lot of things are obviously built in the ocean, and yeah, we're going to learn about it. But that's pretty much it. We're going to check this out. Hopefully you're going to enjoy. Links are in the description to my Patreon, where you can see reactions that I can't post to YouTube, movie reactions, TV series reactions, all that good stuff is there. But let's jump into this and see how engineers do this. Yeah.
Many laborers are fighting hard against the violent ocean currents to complete the construction of an underwater bridge pier. Are you able to spot a mistake made by the chief construction engineer here? This mistake will result in a catastrophe. Welcome to civil engineering's most challenging task.
Maybe I'm wrong.
Underwater construction.
I think I based it off this, right? I saw this in the thumbnail, or I saw this at the start, and I thought, okay, they make those, but I guess maybe that doesn't work.
Even though we call it underwater construction, today's engineers avoid water altogether when building an underwater structure. To remove water from your construction area, you must first build a temporary dam called a cofferdam.
Okay.
Working directly under the water is far from a practical method. The next question that arises is how to build the cofferdam under the water. The first step is to erect these guide piles with the help of a pile-driving hammer machine. The guide piles provide guidance for the construction of the cofferdam. Then, workers will drive many sheet piles in the soil with the help of the same machine. These sheet piles have interlocking connections at both ends of the section. Such a clever interlocking mechanism means that water leakage will be minimal. The sheet piles are driven under the ocean bed till they reach the bedrock. The order of piling is from the corner to the center. The alignment can be maintained this way. Have you noticed anything special about the pile-driving hammer machine? It isn't just pushing the sheet piles down. You can imagine easily what would happen if the sheet piles were pushed into the soil. To penetrate the soil, the machine uses vibration. If you observe carefully, you'll see these tiny but fast vibrations. The specialty of this machine lies in the fact that it consists of two counter-rotating eccentric weights. The purpose of these weights is to induce vibration in a machine.
What the hell?
This flat surface-looking ship called a barge is employed to carry machinery and components that are required on the construction site. Now we're ready for the big phase of the construction project, pumping out the water from the cofferdam. However, before doing all this work, the engineers had a major assignment to do. Let's see what this was before getting into the water pumping phase. The engineers of the project had to do a detailed geotechnical study of the soil on which the cofferdam was going to be constructed. They selected the land so that it would be able to carry the load of the permanent structure. The most commonly used test for measuring soil strength is an in situ test called a cone penetration test. You can see how the cone penetration test device is kept on the ocean bed. The conical tip of the device penetrates in the soil, and sensors send back friction and soil resistance values.
What? How is technology even doing this stuff? What the fuck?
Continue the penetration till the point they reach the bedrock. You can see the sudden jump in the resistance value once the bedrock is reached. With the help of this handy test, the engineers know how deep the sheet piles must be driven. The sheet piles should reach the bedrock. Now let's jump back to the project and begin pumping water out. As the water level lowers, you'll notice water leakage between the sheet piles. This is due to differential pressure of the water. Single layer sheet piles are failing, so we need to double them. The space
Oh.
between these walls of sheet piles is generally filled with granular material, such as sand, gravel, or broken rock.
Because they've got to have a lot of sand or broken rock then. That's going to be... I don't know how long this is all taking as well. Like, what's the timeline of all this happening? It's probably, what, a few weeks?
This double-layered cofferdam will effectively resist water leakage between the sheets. Now, let's remove all the water from the cofferdam. Luckily, there's no visible water leakage. Oh no, what happened? The entire cofferdam collapsed inward.
That would be pain. That would be painful to see happen.
Earlier, when the water was present on both sides, the force acting on the cofferdam due to the water pressure was being cancelled out. You can easily understand the reason for this. However, when the water from this volume disappears, there will be a huge inward force, which destroys the cofferdam. The inward collapse of sheet piles can be prevented by erecting a bracing frame structure by the side of the sheet piles. The bracing frame system comprises components like wales, struts, and braces.
Has there ever been cases of some like this happening and people being like doing the construction at the time of when it collapses in? That is creepy to think about, man. You got the ocean water just collapsing in. Oh, no, thank you.
The connection between these wales and struts is bolted, as illustrated here. These horizontal members, called struts, provide lateral support, which can resist inward movement to the cofferdam walls. The cofferdam is super strong now, and it's reached the bedrock. Let's dry the water now. Can you predict what will happen now?
Here I have made a cofferdam. A small but cute cofferdam, isn't it? Let's see now what happens if I remove water from the cofferdam. I'm removing the water. The water particles are traveling that a beautiful U shape. The water particles are traveling like a U shape below the cofferdam. This is because of the water pressure differential. The same thing will happen inside our cofferdam as well when you remove water from that.
Similar to the experiment, water seepage happens in our cofferdam also.
Okay.
The technique to prevent water seepage are difficult to accomplish, so let's pump this seepage water out continuously. If the soil above the hard strata is removed and concreting is done on the hard strata, our underwater project is half done. This is called the concrete seal course technique. The concrete seal course will also act as a strong footing, preventing any water leakage. Let's see how this is done. The removal of the soil from the cofferdam is usually done using clamshell buckets. These buckets are operated by an excavator. Doesn't the operation of the clamshell bucket look pretty cool? You know the next stage, concrete seal course. To make sure the concrete seal course is bonded strongly with the bedrock, we need a few piles which penetrate into the bedrock. The vibrating hammer machine comes to help again. It pushes a few hollow steel pipes into the bedrock. The hard rock within this cylinder is removed with the help of an auger machine. Now it's time to place reinforcement bars into the cavity and pour concrete. Once the piles are ready, we can build the concrete seal course above. Since seepage water is present on this base always, the seal course concreting is carried out using the Tremie method. This includes a hopper bucket and a long segmented pipe. Specialized cement with high workability is used to concrete the floor. A thick plug is installed at the bottom of the Tremie pipe to prevent water from getting inside the pipe. After some time, this pipe is lifted with a jerk, causing concrete to pour down and the bottom plug to be removed. During this process, the discharge end of the Tremie pipe is continuously kept submerged in the concrete, so that the concrete which is getting poured is less likely to mix with the surrounding seepage water. Now that the concrete seal course is ready, it's time to tackle the remaining construction work. The water seepage is efficiently blocked by this structure. Workers lay out the skeleton of high-quality reinforced bars to construct the footing shaft of the bridge pier. Because the bridge pier structure is going to remain in the water, engineers ensure that the materials to be used in the construction are of the best quality. They must successfully bear the water pressure as well as the load of the bridge. As the skeleton of the bridge pier keeps on progressing, arrangements are made to pour...
So this is for a bridge pier. I might have to see how it's done. Like, I guess maybe with something like the things I was mentioning at the start. Not what are they called? Wind turbines. Would this whole process be there, or would they just do it? I'm gonna search it because I guess a wind turbine is a lot less complex than this.
Concrete in the structure. Once concrete is completely poured into the skeleton, this structure is kept undisturbed to gain strength. Usually a bridge pier takes 14 to 28 days to gain complete strength. Once the bridge pier gains enough strength, the cofferdam is of no use and is an eyesore, so the engineers remove it. However, removing the cofferdam below the level of the concrete seal course can affect the strength of the whole structure. As a result, engineers cut the sheet piles at this level. Here it is. This strong bridge pier is ready to support a heavy bridge.
I hope you enjoyed.
Well, that's for bridges. Now, how wind turbines? Wait, how are ocean wind turbines built? The foundation. I'm just going to quickly go through this because this obviously wasn't the focus of the video, but I just want to see because maybe it's the same context and the same concept. Sorry, like it's just how they do it. But
Hello, everyone.
my computer is so slow at the moment. I don't know why it's taking so long to respond. So challenges, CJAX. Okay, operation.
Though the operation of these turbines is simple enough, the technology is not.
CJAX.
2015, CJAX sky up to 213 feet.
Damn. So it's with the water, they just literally
The
plant
massive
it in.
deck space is used to carry the wind turbine components and houses the main crane with a massive payload capacity, as well as the 2 auxiliary cranes to hoist the components during installation.
God damn. Well, then it's a lot. I guess it's a lot less complex with this. I don't know, but there we go. This is a fascinating look into the world of building stuff on the ocean or just in water. And yeah, it's a fascinating little look into it. Hopefully you enjoyed. And until next time, subscribe and peace.